It looks like you're back for some more Cramer's rule. Welcome back to our final, really the final. In this video, I'm only going to focus on a 3x3 linear system and how to use the Cramer's rule and the determinant to solve that, okay? But when I introduced this to you guys, I didn't think I did a very good job. So to get the x for this linear system here, you calculate this, but this is actually d sub x. Let's actually give it some labels, right? And this guy is my determinant of my coefficients. Now this guy is d sub y. It's good to label these because we're going to be using this notation as well, okay? So d sub x, d, it's when your x values get replaced with the constants. D sub y is when when your y values get replaced with the constants of the actual linear system. Looking at this here. And your D is your determinant of your coefficient matrix, okay? So now we're going to try it with a 3x3, okay? 3x3 matrix or a equation with 3 unknowns. So I have this following problem. Use the Cramer's rule to solve the following linear system. So I have this linear system here, and I'm going to show you with another example how to use the Cramer's rule to solve this guy here, okay? So let's go ahead and do that, okay? So number 24 from your textbook, 8.5. What's the first thing you should do? What I think you should do is this. I think you should, okay, so if you want, you can actually create this into a matrix. 4, 2, 8. So if you want to keep track of your ABCs, right? -5, right? 3, 5, -2. I'm going to write this into an expanded form. So I have my x, y, z here. And here's my constant C1, C2, and C3. So again, this is my A, B, and C in this case because we have 3 equations, 3 unknowns. Okay? All right, so we're going to be using this. But the first step is the same. First step, let's calculate our major D. And D is always the matrix determinant of your coefficient matrix. So we're going to calculate the determinant of 4, 2, 8. Now, I want you to use a calculator for this, okay? Calculator, please. Otherwise, it's going to take too long, okay? On the test as well, you're going to get a calculator section for Cramer's rule. -2, 2, -5, 3, 5, -2. Now, punch it into your calculator. What do you calculate for the D, determinant? Did you get 0? Did you get 0? I hope not. Did you get -82? I hope so. So I got -82 for D, okay? So that's my first step. What was my second step? Do you remember what we did for our second step? You're right. Let's calculate in order, okay? Just remember, let's write some notes here. X is equal to d sub x over d. Y is equal to d sub y over d. Z is going to equal d sub z over d. This means it's the coefficient matrix with the x column replaced with C, right? And this means the coefficient matrix with the y column replaced with the C. And Z is when the third column is replaced with the C, determinant of, okay? So let's go ahead and calculate the second thing. The second thing we have to calculate is our d sub x, okay? So let's calculate our d sub x. Our d sub x, it goes like this, right? Our d sub x is going to be our coefficient matrix. I'm going to put this up a little bit. What's our d sub x? Our d sub x is -2, 16. I'm sorry. I'm going to look at this, okay? -2. I'm looking at the wrong problem. So -2. Oh, sorry. Oh yeah, -2, 16, and 4. Sorry, I was looking at the wrong thing. It's because it's our C column, right? So you know what? Maybe I should have this guy at the bottom here so we can see that. We can see that, okay? Sorry. So we replaced -2, 16, 4 because we're taking the column because we're looking for the X, right? So the X column is the weird one, okay? And then the Y and the Z stay constant. Go ahead and put this into your calculator and see what you get. And you should have got that d sub x equals, I have all the values for us, okay? Did you guys get -4, 10? I hope so, okay? Now let's go ahead and calculate d sub y. If you want to stop the video and then try it on your own, you can stop the video, okay? So I'm going to do d sub y. d sub y, I get the matrix as this, okay? I get 4, 2, 8. I replace -2, 16, and 4. This is the weird one because we're doing the y. And z is 3, 5, -2. And when I calculate this, go ahead and punch it in your calculator. I got -6. Oh, I'm so shaky, huh? -656. Okay, is that what you got? Calculate your dz. Set it up. 4, 2, 8. The y stays the same, -2, 2, -5. And your y column changes, z column changes, -2, 16, 4. Okay? So I get, what do I get for that? I get 164. All right? So these are my d sub x, d sub y, and d sub z. Now, let's go to our third step. What is our third step? Our third step is to use all this, right? Remember, and also remember, d was equal to -82. We calculated that on the other sheet. So I got d sub x over d. Y equals d sub y over d. Z equals d sub z over d. Okay? So d sub x is -410. D is -82. D sub y is 656 negative and -82 for d. D sub z is 164 and -82. And when I calculate those, did you guys end up with 5, 8, and -2? So conclusion, okay? This is the third step. Our fourth step, conclusion. Our x, y, z is going to equal 5, 8, and -2. Now, I know what you're thinking. You're thinking, why would I use the Cramer's rule to solve a linear system of this? I can just run it on my calculator as a matrix using REF or REF. You're right. But this is sort of the way that your computers actually operate. So if you're a programmer, it's useful to know this method. And this is how your computer thinks, okay? All right, guys. Also, one last thing. What would happen if your determinant of your coefficients, your d, ended up being a 0? Then you're right. What does that mean for a linear system? It probably means that your one of the variables is dependent. So it's like a dependent system. So again, if your d became a 0, that means you can't divide by 0 on any of these. So it could kind of mean maybe that it has an infinite solution or a dependent consistent system. Okay? All right, we'll discuss that more when I return. Have a good time. Bye!